Hello everyone. In today's video, we will explore Java virtual threads, which got introduced as a preview feature in Java 19. Virtual threads are particularly useful for applications with concurrent blocking operations. Before diving into the details of virtual threads, let's first try to understand how things were handled with traditional threads, also known as platform threads. A platform thread is implemented as a thin wrapper around an OS thread. In Java, a platform thread, also known as a traditional thread, maps directly to an OS thread. This means that each Java platform thread corresponds to a single OS thread, and OS is responsible for scheduling and managing these threads. The number of available platform threads is limited to the number of OS threads. Platform threads typically have a large thread stack and the reserves that are maintained by the operating system. Virtual threads is introduced in Java 19 as a preview feature. Virtual thread is also an instance of thread class. However, a virtual thread isn't tied to a specific OS thread. So, one OS thread is equal to multiple virtual threads. A virtual thread still runs code on an OS thread. Until this point, everything is same. However, when code running in a virtual thread calls a blocking IO operation, the Java runtime suspends the virtual thread and the OS thread associated is now free to perform operations for other virtual threads. In this way, OS threads can be reused by multiple virtual threads. To simulate a lot of threads, the Java runtime maps a large number of virtual threads to a small number of OS threads. This image gives a clear picture about Java virtual threads. If you see from bottom to top, a single platform thread corresponds to a single OS thread. But after Java 19, a single OS thread can be controlled by multiple virtual threads. If there are any blocking operations in the virtual threads, the OS thread can be reused by other virtual threads. Virtual threads can be used in high throughput concurrent applications, especially those that consist of great number of concurrent tasks that spend much of their time waiting. Server applications are one such examples. And keep in mind, virtual threads are not faster threads. They do not run code any faster than platform threads because they are still using platform threads. Virtual threads will be beneficial when we really use it for blocking concurrent applications like reading file, calling HTTP APIs, etc. They exist to provide scale, high throughput, but keep in mind, not speed. Let's try to create a new class, virtual thread example. We can have our main method inside it. And let's try to create a thread builder. We can use thread.opVirtual, which in turn will give the thread builder instance. And we can pass name as worker and another argument, which is a random value starts with 0. So in this turn, the name will be worker-0. And then we have to create a runnable task. This runnable task will just print the thread ID. Now can create our thread with the builder, which we already have. We just have to use builder.start and we can give our runnable task as a param. And next we can use t1.join, our thread instance.join. This will wait for the thread to get completed. We can also create another thread t2 using our builder and we can call this start method. We can use t2.join and then we can just print some logger here with the thread name. And finally, we can run this application and we can see the result stating thread ID 21 is started, worker 0 terminated, and thread ID 24 started and worker 1 is terminated. This is not a great example to show the power of virtual threads, but this example demonstrates how to create a virtual thread with Builder and how it gets executed. Thank you for watching my video. See you all in my next one.